I'm Jarkko Lipponen. I'm Chief Product Officer and co-founder of Collective Crunch. I'm here to tell you a bit about how to create a dynamic inventory model in forestry. Few words about us. We are a startup founded in 2016. We're a Finnish-German firm. We have offices in Sweden, in Finland, also, of course, in Germany, in Berlin. We were now second year in a row. We were included in the top 15 Finnish startups. Thank you very much for FC AI. This is an industry panel together with Finnish Ministry. They are selecting the most promising AI startups every year. And to my knowledge, we are the only company in the world focusing on AI and solutions for forest industry. We are a small company still. We have some team of 20 people, but we are only working on this problem and in this area. So, as many of you know, especially those working in forestry, the current models and remote sensing models for large forest areas, they really have some major challenges. For example, LiDAR gets a very good volume estimate. It's expensive, it's static. Satellite images only, they get a nice species estimate, but then the volume estimate is lacking. When you combine those both, you get a bit better result, but not much. So we have been working for the last 3 years on this problem, and we have a product called Linda Forest. It's now live in Sweden with Sveaskog, with Setra. It's being used by large investment funds in Baltics, and it's just being released in Finland. Now I'm going to tell you a bit about how the trick is done. So we have a massive geographical information system with many layers. Talking a bit about those layers. From this system, by applying several AI algorithms, we can find predictions on what is there on the forest, and also why things happened, and what to do in forestry. One of the layers is imagery. That's why I was asking about the Sentinel-2. We have Sentinel-2 as well here. We have actually many Sentinel-2 images. We have Sentinel-2 near infrared, false color images. We have images which are just pure normal photographs. We have sharpened images. We have tested almost every image source that there is available to get the best results out of AI. We have massive amounts of LiDAR data. The nice thing about having a company here in Nordics is that a lot of things are open, like Finnish National Inventory, NLS LiDAR data is open. You have open sources in Baltics. You have ways to get it in Sweden. There are some images from our system. As you can see, there's just a pure point cloud really nicely illustrates the forest right here. But you also notice that we are focusing on machine learning, so just analyzing LiDAR on a normal level is not enough. So we are pulling out attributes that we see that actually work well with machine learning. That's not a That's not a small feat. If you talk to anybody who has actually worked with LiDAR data, these data sets are huge and complex and require a lot of cleaning up as well. We have a weather layer. Last years there has been, especially with European Space Agency, there have been a lot of very positive developments. There, so-called, I think we heard from our colleague here from Meteorological Institute, there have been these kind of reanalysis data sets released. This means, for example, weather analysis from ESA, you can get over 50 years back in time, you can get the weather in a grid level. Just think about it. Now we are calculating the forests mainly with the growth with heat sums. We can now generate daily models for very specific forest areas with these sets. Very, very useful. You have different things like precipitation, wind, for example. It's a big, anybody who's dealing with sawmills knows it's a huge aspect on the quality of the trees. And silviculture data. So we have a lot of silviculture data, private, non-private data on how forests have been maintained, how the whole circulation of forestry has been done, how people have fertilized the lands, and how they have performed their thinning operations. Especially, it has a huge impact on the growth of the trees, together with fertilization or ground. Then we have harvester data. We saw yesterday the ground LiDAR data. We have a lot of that data on the GPS positions. So here you're looking at an image from our system. Every single dot here is one tree that has been harvested. More darker, the one grid, more volume, more cubic meters came out of that grid. Just for information, usually the GPS is in the harvester machine, so the GPS data is slightly off, but we have found ways to how to actually correct that. In Finland, not many people produce yet GPS-based data. It's moving there. So our partner Metsähallitus is actually at the moment producing with 30 harvesters every day GPS data for our data processing. So, any forester would know soil, bonitet, has a massive impact on the actual growth of the trees. We have different soil layers. We have global soil layers. We have local geographical institute soil layers in the system. We have also private analysis of soils, bonitets. This is built into the models, how the forest grows. This is an important aspect as well, to take into account the elevation. It's a big difference if the tree grows on a hill, in a recess, where there is a lot of water flow into the soil. So if you know where the tree grows in elevation together with soil, together with weather, you get very powerful stuff for artificial intelligence to process. Several elevation layers, local ones. Also, this one is from Copernicus, which is the European Space Agency, producing the layers. So, then we combine everything together with Linda, for example, create forestry predictions in very, very accurately. And why we say accurately? Because the funny thing about the forestry predictions is that a lot of people make predictions, but they never prove them. As we are from our customers, we are all the time, we are receiving harvester data. We are measuring our predictions against the harvester data. We can't hide, so to say. So we always need to be the best. So shortly I'm going to tell about the case study. It's a Metsähallitus, Finnish forest government. They own this building, they own the forests around here, biggest forest owner in Finland. Altogether 10 million hectares, in active use 3.5. There was a huge tender, 14 companies in Finland, global companies. They were looking for an AI partner, and we won that tender with the approach that I just showed in here. So here you can see our grid level predictions. So we generate into millions of hectares, we can generate any kind of grid level predictions. It's extremely accurate. The grid size doesn't really matter to us. We have 20-meter grids, 16-meter grids. We are looking into smaller grids as well. It's just what really makes sense. In this case, 16-meter makes sense. Just checking if there is the pointer. Yeah. So it's all great if you can see good predictions, but what you can do with it. So we were presented a huge challenge by Metsähallitus is to actually generate cutting shapes. This is traditionally very, very demanding. So a forest shape, how to cut is usually done manually. The planner of forest goes to the forest to check if the forest estimation is right and if the shape is right. So we have here 3 AI algorithms working in perfect unison. One is doing the grid level predictions. One is doing an estimate. We have actually taught from Metsähallitus the planners how they do the shapes and when they do them. In here, when to cut, what kind of cutting to do, if to do the first thinning, the thinning, or the regeneration or harvest, or not at all. And we are getting very, very close to the actual planners with the system, just to make the shapes. And of course, it wouldn't be good system or for a planner if it wouldn't be easy to use. So the planner can select the shapes, usually, for example, for one operation. They can download it into their GIS tool, use it immediately, put it into the production. Estimating that this saves millions of euros every year. The results have been very good, and the partnership is continuing for foreseeable future. We are also rolling out this feature to our larger forestry clients. We are talking about several pilots at the moment, and we are adding more things in here, like more accurate growth models of forest with a similar approach. So thank you very much. Please follow us on LinkedIn to get all the up-to-date news. We try to make some videos nowadays. And please feel to contact me anytime.
To know that you mentioned about the artificial intelligence solution. So are you developing your own artificial intelligence solution, or are you using existing and just applicate to your solution?
That's a good question. So there are 2 main ways to do it. You can use existing systems that have building algorithms, or you can use the libraries that you program by yourself. So we are a bunch of AI data scientists and programmers, so we are programming all of this by ourselves. And all the system is completely developed by us as well.
So I'm interested also about some layers where you're using the color images.
Yes.
Are you doing some automatic color correction, or is this your own technology, or are you using some other?
Right. So we have a other startup as a partner called Terra Monitor. They have a extremely good image processing platform for satellite images. If you need satellite images, I would very much recommend them. So we are not doing that by ourselves.
I am Pille Kaus from Estonian software, Forest software company.
Yes.
You mentioned that you have some projects also in Baltic states.
Yes.
We are struggling with the fact that in Estonia and in Baltic states there are more tree species than, for example, in Finland. Have
Right.
you also got this difficulty
Yes.
in
So
detecting tree species?
yeah, actually, I believe we are the first company that has made predictions to all the private stands in Estonia. So yes, we have predictions. They are very accurate. Happy to talk. Specifically on the deciduous species. For our clients, for the deciduous mix is not so important, at least the ones that we deal with at the moment. As long as they know the deciduous is there. So it's pine, spruce, and deciduous. If needed, we are happy to build a model for deciduous mix as well. Does that answer your question?
Hi, Rob Connell from Knoll Venture. Thank you. Have you received any inquiries, or do you think there will be a trend to have some demand from carbon trading, verification, and brokerages?
Yes, good question. Yes, we have, and as we are knowing the forest inventory in the most accurate level, we can make a very good model on CO2 and CO2 flows. We are working on that.